Are you a student struggling to keep up with your lessons? Or a parent searching for a reliable educational resource that truly cares? You've come to the right place. Welcome to FEUNIX Distinctions, your premier channel for educational content designed for every learner. We understand the silent struggles that often go unnoticed, the frustration of slow-paced learners, and the need for solid foundations for all students. At FEUNIX Distinctions, we don't just teach. We are dedicated to guiding you every step of the way. Our teaching style is unique, simple, and incredibly effective. We make complex concepts easy to grasp and ensure that every lesson is both suitable and enjoyable, no matter your learning pace. Whether you're a fast learner looking for a new challenge or an average learner aiming to excel, our comprehensive methodology is built to support you. Join a community where no one is left behind. Subscribe to FEUNIX Distinctions today and hit the notification bell so you never miss a lesson. Let's make learning an exciting journey together.
I welcome you all to today's class. This is SS2 Mathematics class, Lesson 7. We are still on the topic Cycle Geometry. In this Lesson 7, we are going to continue from where we stopped in Lesson 6. We are not going into a fresh subtopic. We'll still dwell on this Theorem 11. I just want us to solve more examples on Theorem 11. That's what we are going to basically do today. More examples on Theorem 11. In Theorem 11, we're meant to understand that angle at center is twice angle at circumference. And we explain how to detect angle at center and angle at circumference. There are some properties that the angles must possess, and they are basically two. The takeoff point, the landing point must be the same. The takeoff point of the line that forms the angle at center and angle at circumference, they must have the same takeoff point, and they must have the same landing point. They must land at the same point. They must take off from the same point and land at the same point, and the angles must face the same direction. Those are the two things: takeoff and landing point, then the direction. We solved 2 examples, so I feel we should solve more examples to gain perfection. We are not rushing. What we need is perfection. And so let's solve more examples, including the homework all together, so that we can be able to get it. We have to find the angles. I'm going to draw cycles, then we'll find the angles. Find the lettered angles. 1. We're drawing a cycle now. So we have 41 here. And then here we have Q. In the last class, we said these are angles. Angle at center is twice angle at circumference. Because this very angle Q, it took off from here. And then this is the straight line. And it landed here. And then this angle 41, it took off from here. That same place that this angle took off. So this angle 41 forms an angle at the circumference here, and then the angle came down here and landed here. So they have the same takeoff point and landing point. They have the same takeoff and landing point, and then they are facing the same direction. This one is facing down, this one is facing down. This is the only case where you can use angle at center is twice angle at circumference. So since these two properties are there, we can be able to get angle Q. Angle Q will be twice angle 41. So angle Q equals to 2 times 41. Angle Q equals to 82 degrees. It's as simple as that. Let's solve another example. We're here basically to solve more examples. I don't just want us to be jumping from one topic to another. It is not how fast, it is how well. So we have another cycle here. We have another cycle here. This is the center O. This angle is 106. This angle is angle R. We want to find angle R. If you look at this work, you will see that this angle 106 have a takeoff point here. This is where it took off. Form an angle here, and then it landed here. The same thing with this angle R. It took off from that very point, took off from here too, took off from here, form an angle at the circumference, and then it landed here. So this angle 106 and angle R have the same takeoff and landing point. That fulfill one of the law. And then this angle R is facing down, and this angle 106 is also facing down. That's the second one. They are facing the same direction, and they have the same takeoff point. So we can apply angle at center is twice angle at circumference. So if angle at center is 106, which is twice this angle at circumference, that means angle at circumference will be half of it. If this one is twice this one, that means this one is half of this one. Half means divided by 2. So if you are moving from center to circumference, it's divided by 2. If you are moving from circumference to center, it's times 2. So angle R is equal to 106 divided by 2. Angle R will be equal to 53 degrees. That's our answer. Let's solve another example. We are here basically to solve examples. Example 3. We're going to draw another cycle. We are going to draw another cycle. We're drawing another cycle to solve example 3. Drawing cycle. So this is the center of the cycle, which is center O. We have an angle here. Let me double the line. This is angle S. There is an angle here, which is angle 126 degrees. We have to find this angle S. So we have to look at this carefully. It has been two laws: takeoff and landing point and direction. This is angle at center. This is angle at circumference. Do they fulfill these two laws? Let's look at it. This angle took off from here, and then it forms an angle, and then it landed here. This angle at circumference took off from the same point, touched the circumference, form an angle, and then it landed the same place. So since they have the same takeoff and landing point, that is one of the things to check. And then the direction is 126 is facing down. And then this angle S is also facing down. So they have the same direction and the same takeoff point and landing point. We can use the theorem. So let's use it. Angle at center is twice angle at circumference. So if angle at circumference is 126, angle at center will be twice. It will be 2 times 126. 2 times 126 is 252 degrees. And that's our answer. We're going to continue with example 4. Example 4. We'll draw a cycle. We're going to draw a cycle. We have here a cycle. This is the center of the cycle. So this is angle T, and then this is angle U. This angle is angle 135. Angle 135 degrees. Now let's analyze this work. Now it will not be advisable for us to start with this angle U. This angle U and angle 135, they have something in common and they also have a difference. What do they have in common? They have the same takeoff and landing points. Takeoff and landing points. Angle U took off from this point, formed this angle, and it landed here. This is the takeoff point, this is the landing point. While angle 35 also took off from here, formed an angle at the circumference, and landed there. So they have the same takeoff point and landing points. But the direction angle U is facing is down, while angle 135 is facing up. That's the difference they have. So since the direction is not the same, we cannot use sum of angles at the center is twice angle at the circumference. Let's look at this angle T, and I feel that's the angle we are to start with. Angle T also took off from here, this same place, formed this angle and landed here. Same thing with angle 135, have the same takeoff and landing point. Angle 135 is facing down, angle T is also facing down. So they have the same takeoff and landing point. That is why we are starting with angle T. So angle T is angle at the center, angle 135 is angle at the circumference. So if we are to get angle T will be twice the angle at the circumference. Angle T will be equal to 135 times 2. Angle T will be equal to 270 degrees. We have found angle T. At this point, we can get our angle U. Angle U with ease. Using sum of angles meeting at a point is 360. This is it, a complete cycle. It's 360. So if you know from here to here, as 270, you will kindly do 360 minus 270. That will give you this angle. So angle U is equal to 360 minus 270. Angle U will be equal to 90 degrees. Let's solve another example. Example 5. Example 5. Okay, so this is the middle or the center O. We have angle V here. We have angle 32 here. Let me call this angle W. We have to find angle V and angle W. Please, I want you to watch carefully in order to apply all these things that we have been talking about. If you watch this angle V, you will see that the formation of this angle is from here. This is the line that forms it, and this is the line that drops it. It dropped here. So this is the takeoff point, this is the landing point. Also, this angle 32 have the same takeoff point, and also the same landing point. So this is the angle at center, and this is the angle at circumference. The angle at center is twice the angle at circumference. From here we can now find the value of our V. Our value of V is 32 times 2. That will give us 64 degrees. We found our angle V because angle at center is twice angle at circumference. What about the direction they are facing? It's so very crucial. It's facing down, and this one too is facing down. They are facing the same direction. That is why we use angle at center is twice angle at circumference. Remaining this W. This W is angle at circumference. This angle W, the formation of this angle have the same takeoff point and landing point. This is the landing point, the same takeoff point and landing point. So if angle V is 64, if angle V is gotten at 64, then angle at circumference will be half of it. That is to say, this angle W is 64 divided by 2, that is 32 degrees. So what are we seeing here? This angle 32, that's this angle, and angle W, they are all the same. They are all equal. When we reach one of the theorem, we are going to see it. Angles in the same segment are equal. Let's add one more example in order to round up with this work. Example 6. Example 6. This angle is angle 119. This is angle Y. And this is angle X. And this is angle Z. This is the last example here, so I want you to watch carefully. Looking at this shape, which angle are we going to start with? Logically, it will be better to start with this angle X. Angle X. Because angle X have direct relationship with this angle 119. What's the relationship? The formation of this angle X, have the same takeoff point. This is the takeoff point. This is the landing point here. The same takeoff point and landing point with the formation of this very angle 119. Yes, we have the same takeoff point and landing point, and both of them are facing down. This one is facing down and this one is facing down. So we can use angle at center is twice angle at circumference. So if this angle is 119, then definitely angle X will be 119 times 2. Angle X will now be 238. 238. So now that I've gotten this one as 238, I can easily get this angle Y using sum of angles meeting at the point is 360. A complete cycle is 360. So if this one is having 238, then definitely angle Y will be 360 minus 238. So angle Y will be 122. Angle Y will be 122 degrees. We have gotten this angle. Remaining this angle Z. For this angle Z have a relationship with angle Y because they have the same takeoff and landing point with this angle Y, and they are facing the same direction. This one is facing up, this one is also facing up. So therefore angle Z is equal to this angle Y divided by 2. Because if you are moving from center to circumference, you divide by 2. That will be 122 divided by 2. That will give us 61 degrees. So we are going to stop at this point. I will encourage you to always click the subscription button. Also click the like button and the share button. Thank you and have a nice day.